Okay, question number 1. In a right triangle, the given legs are A is equal 18, B is equal 27. So, using Pythagorean Theorem, find hypotenuse C. Okay, the formula for hypotenuse C is, for the right triangle, C squared is equal A squared plus B squared, or hypotenuse square is equal sum of leg squared. Okay, so what do we have? Here we're gonna have C squared is equal A squared, which is 18 squared, plus 27 squared. And C from here is going to be equal square root 18 squared plus 27 squared. Okay, this is going to be equal 324 plus 729. And we are getting 1053. So we can break down into 81, square root of 81 times square root of 13. So you are breaking down the way, so at least partially you can take it out. Square root 81 is 9, and square root 13 stays underneath. Okay, so that means C is equal 9 square root 13. Okay, similar problem is the next one. So we have A is equal 6 and B is equal 16. So we need to find C. C is our hypotenuse. And hypotenuse, how do we know that it's hypotenuse? It's laying right against the right angle, 90 degrees. Okay, so C is going to be equal square root A squared plus B squared. Yes, using this formula. Okay, so this is equal square root 6 squared plus 16 squared. This is going to be equal 292. And I can break down into 4 and 73. 73 times 4. So, which means I can put 73 times square root of 4. Let me clean this so it won't be confusing. Okay, and we have square root of 4 is 2. Square root 73 will stay underneath. Okay, next question. So, using identities, find the exact value of each of the 4 remaining trigonometric functions of the acute angle theta. Our theta is acute angle, so to find the remaining trigonometric functions, it's going to be tangent theta, cosecant theta, secant theta, and cotangent theta. Okay? So before I go further, Let me write down all identities. So, tangent is equal sine theta over cosine theta. Cotangent theta is equal cosine theta over sine theta. So from here we can say that tangent theta is equal 1 over cotangent theta, and vice versa. Cotangent theta, let me see. Cotangent theta, and vice versa, gonna be cotangent equal 1 over tangent. Okay, next, cosecant theta is 1 over sine theta. Secant theta is 1 over cosine theta. All right, so far so good. This is good enough. I will add as we need. So let's start working. Since I have sine and cosine, so what I can find out right away? Tangent, right? Okay. So tangent is equal, tangent theta is equal sine theta over cosine theta, which is equal 2 over 3 dividing by square root 5 over 3. Okay, so from here we're gonna get, oops, sliding down, it's equal 2 over 3 times, we flip the second fraction, right, division of fractions, 3 over square root of 5. So 3 and 3 is gone, and we are getting 2 over square root of 5. We can't have square root any radical in denominator, therefore we are going to rationalize, which means I'm going to multiply and divide by square root 5, which means here I will get 2 square root of 5, and in denominator I will have only 5. It will come out. Okay? Next. So let me write down here the answer. So tangent theta is equal 2 square root of 5 over 5. Okay, moving to next one, cosecant theta. Cosecant theta, where is the cosecant theta formula? It's right here, 1 over sine. So it's equal 1 over sine theta. So 1 over sine, which means 1 divided by 2/3. So that's going to be equal 1 divided by 2/3 is equal 3 over 2. Okay, this is cosecant. Let me write down. All right, next Let's do secant. Secant theta is equal 1 over cosine theta. And that is equal 1 divided by square root 5 over 3. Let me pick this. Okay. Actually, I don't like it. It got too much shrinked. Much better. Okay, so this is equal 1 times 3 over square root of 5. Yes? Okay, so we need to do rationalization, so which is going to be times square root of 5 times square root of 5, and the answer is going to be 3 square root of 5 over 5. So from here, secant theta is equal 3 square root of 5 over 5. Okay, what we have left? Cotangent. We have left cotangent. Cotangent theta is equal 1 over tangent theta, right? Or you could take cotangent theta is equal cosine over sine. That's also, we could work. But 1 over tangent, I like it better. So tangent, we have 2 square root 5 over 5. Here it is. So therefore, it's going to be 1 divided by 2 square root 5 over 5. So it's going to be 5, 2 square root 5. So let's rationalize. And I'm getting 5 on the top. Okay, so we get 5 square root of 5, and at the bottom we get 2 times 5, which is going to be gone, and the answer is going to be square root 5 over 2. So from here, cotangent theta is equal square root 5 over 2. All right. Moving to next one. So we have sine theta and cosine theta. Again, we have to find the rest. Remaining identities. So let's start. Tangent theta is equal sine theta over cosine theta, which means 5 over 7 divided by 2 square root of 6 over 7. Okay, so it's going to be 5 over 7 times 7 comes here, 2 square root 6 here. So 7 and 7 gone. And we are getting 5. I'm rationalizing right away. square root of 6 here. At the bottom I have 2 times square root 6 and square root 6. So the answer is going to be 5 square root of 6. Here I will get 2 times 6. Okay. 5 square root of 6 over 12. All right. Did I use everything? 5 times 7, and then 7 comes on the top. Okay. Yeah, we are good. Moving to next. So tangent theta is equal 5 square root of 6 over 12. Next one. Cosecant. Cosecant theta is equal 1 over sine theta. Let me see if I can bring down this formula. Trig functions identity, bring down so we can use it. I will try to move it down as we use it. There we go. Much better. Cosecant is equal 1 over sine theta, which is going to be 1 over sine theta, so 5 over 7. I'm going just to flip it, will be 7 over 5, because 1 divided by 5 over 7, it gets 7 over 5. And we have here the answer. So let me change the color here, so you will have so understand that this is the final answer. And next we have tangent, secant, cosecant. So secant. Secant theta is equal 1 over cosine theta, which means now I'm going to flip cosine theta. It's going to be, if I take 1 divided by 2 square root 6 of 7, that means I'm going to flip it. It's going to get 7, oops, 7 over 2 square root of 6. So if I rationalize, it's going to be 7 square root of 6, 2 square root of 6, another square root of 6, and we get 7 square root of 6 over 12. Okay, and lastly we have cotangent. So let me answer this solution. Secant theta is equal 7 square root of 6 over 12. And lastly, let's do cotangent. Cotangent theta is equal 1 over tangent theta, which is going to be equal, tangent theta is 5 square root 6 over 12. So I flip it, I will get 12, 5 square root 6. For the people who are wondering why I'm flipping, because if you divide 1 by any fraction, you will end up flipping that fraction. Try to divide and you will see. Okay? So, and this is going to be equal 12 square root of 6, rationalizing obviously, and we get 5 square root of 6 times square root of 6. And the answer is 12 square root of 6, and here 5 times 6. So we cancel, this is 1, this is 2, and we are getting 2 square root of 6 over 5. And let me write down cotangent theta is equal to square root of 6 over 5. Okay, now it's given tangent, which means we are going to find sine, cosine, cosecant, secant, and cotangent. All right, let's start working on it. So, tangent is equal 1 over 9. So, from here, what do we have? So let me draw the triangle with the right angle. Okay, so we have here A, here we have B, and this is our triangle, and this is C. So, based on definition, tangent theta, okay, if this is my theta, let's say, so tangent theta is equal opposite leg over adjacent leg, A over B, which, and it is equal, we know it's given 1 over 9. So from here I can say that A, so hence, this is symbol of hence, A is equal 1 and B is equal 9. Okay? Next, you know what? Let me write down all identities from Pythagorean Theorem, because that's where from it's coming. Let me write down. So sine theta from the triangle with the right angle, sine theta is equal A over C, opposite leg over hypotenuse. Okay, cosine theta is equal adjacent leg to hypotenuse. Next, tangent theta is equal opposite leg to adjacent leg. Cotangent theta is equal adjacent leg to opposite leg. Next, secant. Since secant is 1 over sine, the secant is 1 over cosine, which means and cosine is B over C, so we're gonna flip, it's gonna be C over B, which gonna be hypotenuse to adjacent leg, and cosecant is gonna be hypotenuse to the opposite leg. This is why cosecant is equal 1 over sine theta, and this is why secant is equal 1 over cosine theta. Okay, we are good. So, and we found out that A is equal 1 B is equal 9. So from here, can we find hypotenuse once we have A and B? Yes, based on Pythagorean theorem, C squared is equal, right? Hypotenuse squared is equal A squared plus B squared. So C squared is equal 1 squared plus 9 squared. So from here, C is equal square root 1 squared plus 9 squared, and we are getting square root of 82. Okay, once we have square root of 82, so which means we have already A, we have B, and we have C. Let me write down. Oops. So C is equal square root of 82. So here is first data we have, second one, and here is third one. So from here it's gonna be easy. All we're gonna do, apply the formula, identity, and we are good. So let's get going. Sine theta is gonna be equal 1a over c, which is 1 over square root of 82. And that is equal 82 square root of 82 over 82. So I multiplied both sides, square root of 82, and got the result. Next, cosine theta is equal B over C, and it's equal 9 over square root of 82, right? So if I multiply on both sides, square root of 82, let me do this time, just specifically for the people who were wondering. Okay, and this is going to be 9 square root of 82 over 82. Yes? Secant theta is equal C over B. Or I can put 1 over sine theta also. I mean 1 over cosine theta, I'm sorry. Which is going to be 82 over 9 square root 82. So this is equal 82 square root 82. Here 738. Why? Because once I multiply on both sides square root of 82, multiply here square root of 82, here square root of 82, and at the bottom 82 clean come out, and you multiply 82 times 9. Okay, so this is going to be equal 82 and 738. You can cancel. This is 1, this is 9, and we are getting square root of 82 over 9. Okay, cosecant. Cosecant theta is equal C over A is equal 1 over sine theta. And that is equal square root of 82 over, well, I'm going as a C over 8 this time. I'm using this one. Instead of doing 1 over sine, I'm using c over a. So we can see. This is a. So square root of 82 divided by square root of 82 over 82, right? Okay, this is equal. Square root of 82 divided by square root of 82 over 82. Too many 82s, huh? And we are getting over 82. This is gone, and the answer is 82. All right, we got that one also done. Moving to question number 6, now secant is given. So once secant is given, let's see how we can work this out. So I'm going to draw triangle with the right angle. Okay. This is our right angle. All right. So what do we have? If this is my alpha, let's say, this is A, this is B, two legs, and hypotenuse will be C. So secant is equal 11. So based on identity definition, let me bring this here. Down, identity formula. Okay. So, based on definition of secant, secant theta is equal C over B. Okay, C over B. So which is equal 11, or I can write down 11 over 1. So from here, I can say that C is equal 11 and B is equal 1. Yes? Okay. So also I know that secant is equal is equal 1 over cosine theta. So from here, hence, this is symbol of hence, cosine theta is equal 1 over secant theta, which is going to be, since 1 over secant theta, secant is 11, so we flip 1 over 11. That will be our cosine. So cosine theta is 1 over 11. Okay, next. Now I need to know A, because I need to find out sine, cosine, cosecant, everywhere where sine is participating. So I can find sine from the definition of the Pythagorean theorem. So sine, it's what's the definition of sine? That is A opposite leg over hypotenuse. So we need to find opposite leg, which is A. So based on theorem, Pythagorean theorem, we know that c squared is equal a squared plus b squared. Look at that. We have c, we have b. Can we find a? Of course. So b squared, a, we need to find a. A squared is equal c squared minus b squared, right? And from here, a is equal square root c squared minus b squared. Okay, if we plug the values, we get 11 squared minus 1 squared, and we are getting square root of 120. Square root of 120. Okay, since it's square root of 120, now let's go get our sine theta. So sine theta is equal A over C, right? This is going to be equal 120 because A is 120 over C. C is 11. And what do we get? I'm going to break down 120 into 4 and 30 over 11. That's going to be 2 square root 30 over 11. That is my sine theta. Since I have sine theta, I can take care of cosecant theta, right? Because C and A, or cosecant theta, is 1 over sine. Yes. So cosecant theta is 1 over sine theta. Therefore, it's going to be 11 over 2 square root 30. All right. So if I flip, because I have to divide, well, yeah, I already have 2 square root 30. So let me rationalize times square root 30 here. Square root 30 here. And I'm getting 11 square root 30 over 2 times 30, which is going to get 11 square root 30, I'm sorry, over 60. Okay, tangent. So tangent theta is equal sine theta over cosine theta, right? I will recommend write out these formulas and this identity and this one from the very beginning. This is kind of, that's right, here it is. All right. I would recommend to write down them right away from the very beginning. So to have it. So it's equal. Sine theta is 2 square root 30 over 11 divided by 1 over 11. And we get 2 square root 30 times 11, here also divided by 11. We cancel and we get 2 square root 30. Cotangent theta is equal 1 over tangent theta, and that is equal 1 over, where is my tangent? Oh, here it is. 2 square root 30. 1 over 2 square root 30, which is going to be, so multiplying and dividing by square root 30. 2 square root 30 times square root 30. And that is going to be square root 30 over 60. All right? All right, we are done. Now let's solve problem number 7. So next we are going to solve the following operations we have, which is going to be one second. Sine squared 75% plus cosine squared 75%. So we are going to use fundamental identities or complementary angle theorem to find the exact value of this expression without calculators, without calculating. How we are going to do that? Very easy. There is a famous formula for trig function that says sine, let me get bigger one. Sine squared theta plus cosine squared theta. It is proven that sine squared plus cosine squared is equal 1. Pay attention. We have to have the same angle. Do we have same angle? Yes, 75 degrees here, 75 degrees here. Therefore, it's going to be how much? Sine squared 75 degrees plus cosine squared 75 degrees, it's equal 1. Absolutely correct. Okay. Next one. Question number 8. So we are going to solve sine 33 degrees times cosine 33 degrees. All right. First of all, what we're going to do, identify the cosecant. So, cosecant theta is equal 1 over sine theta. Let's apply this. Let's use this. So, cosecant 33 degrees is equal 1 over sine 33 degrees, right? So from here, I can write down sine 33 degrees times 1 over sine 33 degrees is equal sine 33 degrees over sine 33 degrees, and that is going to be equal 1. So the answer we are getting is 1. Okay, moving to next one, tangent times cotangent, 46 degrees. Tangent 46 times cotangent 46. So we know that cotangent theta is 1 over tangent theta, yes? All right, so I can write down that cotangent 46 degrees is equal 1 over tangent 46 degrees, correct? Okay, so from here I can write down tangent 46 degrees times 1 over tangent 46 degrees. And as a result, we are getting tangent 46 degrees over tangent 46 degrees, and that is equal 1. All right, next one. Tangent 15 degrees minus sine over cosine 15 degrees. Pay attention. We can do all this manipulation because degree is the same. If degree would be different, we would have completely different story. Okay? So, we know that tangent theta is equal sine theta over cosine theta, right? So do we have here sine over cosine? Okay, so it's going to be tangent 15 degrees minus, so sine 15 over cosine 15, it's going to be tangent 15, right? The result is going to be 0. All right, moving to next. Now we have different story because we have different degrees. I cannot take advantage of what we had so far, all formulas. Here we are going to use to do sine 75 degrees minus cosine 15 degrees. So here we are going to use complementary angle theorem. Complementary angle theorem says that cosine theta is equal sine 90 minus 90 degrees minus theta. And the same way, sine theta is equal, I will explain this in a minute, 90 degrees minus theta. So, this is a theorem for complementary angle. Now, do we know what complementary angle is or angles are? Complementary angles are the angles if their sum makes right angle 90 degrees. For example, if I take all right, I'll do this way. Okay. And I have this angle in the middle, right here. So let's assume this is 60 degrees. This is 30 degrees. If I add them, I get 90 degrees, right? That means these are complementary angles. Okay? So if sum of these two angles make 90 degrees, then we are getting complementary angles. If angles are complementary, then we can apply these formulas. Okay. So, is 75, we have 75 degrees, oops. We have 75 degrees and we have 15 degrees. Are they complementary? Well, let's check. 75 degrees. My 7 looks horrible. Okay. Plus 15 degrees. It's equal 90 degrees. Right? Therefore, they are cofunctions and they are complementary angles. Okay. So, which means what that gives me? I can write down sine 75 degrees minus cosine 15 degrees. I can write down sine 90 degrees minus 15 degrees based on this formula. Based on this formula. Okay? And this is going to be equal sine 75 degrees minus sine 75 degrees, and we are getting it's equal 0. Okay? And that is the case. The same way I can apply complementary angle theorem to tangent and cotangent. So what do we have? Tangent 21 degrees and cotangent 69. If I add 69 to 25, do I get 90? Yes. Therefore, we have the complementary angles, and we can use theorem, complementary angle theorem, which is going to be, I can apply the same way here, where cotangent theta is equal tangent 90 degrees minus theta. The same way tangent theta is equal cotangent 90 degrees minus theta. All right. So, and we have tangent 21 degrees minus cotangent convert into tangent based on complementary angles theorem 90 degrees minus 69 degrees. And this is going to be equal tangent 21 degrees minus tangent 21 degrees, that is equal 0. All right. Next one. Cosine 9 degrees over sine 81 degrees. Okay, let's see how we're going to solve it and get the value of it. So, 9 and 81, I can call them complementary, right? If I add them up, they are 90 degrees. Therefore, I'm going to write down cosine 9 degrees over sine 81 degrees is equal sine 90 degrees minus 9 degrees. So instead of cosine, so let me move this here. Okay. 90 minus 9, and here sine 81 degrees. And we are getting sine 81 degrees over sine 81 degrees. It's equal 1. And lastly, let's solve this type of problem. 1 minus cosine squared 33 degrees minus cosine squared 57 degrees. Okay, first thing, what we're gonna remember is our major formula, cosine squared theta plus sine squared theta, and that is equal 1. Okay. So, if we have sine squared theta, and that is equal 1, so what can I say? From here, sine squared theta is equal 1 minus, moving over here, right? Cosine squared theta. Does it give me this? Yes. Which means we get sine squared 33 degrees minus cosine squared 57 degrees. Okay, so 33 plus 57, does it make 90? Yes, it does. So we can apply complementary angles theorem, right? And that is going to be cosine squared 90 degrees minus 33 degrees and minus cosine squared 57 degrees. So 90 degrees minus 33 degrees, it's going to be cosine squared 57 degrees and minus cosine squared 57 degrees, and we are getting equal 0. That's all. Thank you for watching, and I'll see you in the next video. Here I have the table of trig functions. Talk too much, and now I need to drink some water. All right, see you in next video.